Hello and welcome back to the SecurityMetrics podcast. My name is Jen Stone. I'm one of the principal security analysts here at SecurityMetrics. A very interesting topic today, something that I think is going to be very helpful to a lot of the security people and compliance people who are listening. Occasionally I'll run into conflict, or not even, maybe conflict is a heavy word for it, but just a little bit of friction between developers and the security team. And so I have someone here today to talk to me about this that is very well versed in it. It's going to give us some really good advice. Let me tell you a little bit about Harshil Parikh. Harshil is a seasoned security leader with experience building security and compliant functions from the ground up. Most recently, he served as the CISO at Medallia, where he built the security and compliance team from scratch, scaled the team globally, achieved compliance in SOC 2, ISO, FedRAMP, went through an IPO and secured more than 7 mergers and acquisitions. He's been a frequent speaker at the RSA conference, AppSec USA, and CSX Europe. Currently, Harshil serves as the co-founder and CEO of Tromzo, a developer-first application security management platform designed to control and secure the software delivery pipeline end-to-end, simplifying security at every step of application development. Harshil, thank you for joining me today.
Thank you for having me here, Jen. And by the way, thank you for the kind introduction.
Well, I think you're going to have a lot of really great information for us, and a lot of organizations already understand this friction. They have experienced firsthand this friction between teams focused on development and those responsible for security. But some of our listeners might not be aware that this is a challenge. Can you describe it for us from your perspective?
Yeah, I would love to. So the fundamental shift that we have seen over the past few years is that every single business wants to be more agile. Everyone wants to do things faster at a cheaper cost and in a more agile way. And that's great. We've seen that happen over the pandemic. Everyone's shifting to technology more quickly. And as a result, companies want to move faster, deliver features faster. But where does security fall into place in all of this, right? So typically, if you think about software development, security has always been sort of that gate where there's change review boards or change approval boards, and everyone has to come in there and get their changes approved before the next release.
Right.
Well, guess what? I mean, that worked when you had waterfall model of development, but it doesn't really work in a DevOps model.
Right.
Even simple controls like change review on code change, right? So if it's in scope of SOC 2, ISO, what have you, how do you know when you have thousands of developers pushing code every single day? How do you know that they're actually reviewing the change? It is being peer reviewed, right? So there's no easy way to enforce those controls at a scale of most companies. So it becomes really difficult to implement even simple controls like that. And then you think about more sophisticated controls like, every single release meeting your compliance controls, you're doing your testing correctly, everything is being tested, risks are identified and resolved in a timely manner. All of those things are almost impossible to do at scale when you have thousands of developers, right? It just doesn't work. So we felt this problem ourselves in our previous life, and there was no easy way for us to solve it. So we decided that, okay, somebody has to solve this. So we started a company to do exactly that.
That's terrific. And I don't want to minimize the problem because I've seen it firsthand. The change to Agile, especially when, like you said, when you have many developers contributing to the code base, the old style of controlling what's getting released just isn't effective. But so I don't want to say that this is a problem we can fix easily or quickly, but maybe there are some quick hit ways that you know of that can better engage developers to take security seriously, or help them use their processes to make security just a part of that flow. What can you recommend on that?
Yeah, I mean, I think it goes back to what developers are really incentivized to do on a day-to-day basis, right? So if you're in an organization where the only priority for developers is to ship new features, that's what they will do. But if their leadership is communicating the expectation that yes, you have to ship features that are compliant, that are secure, then that's what they will do. But in addition to just talking about it, in addition to leaders just talking about it, how do you actually enforce those controls? Like that's the key component, right? Like so then what we have to shift our mindset to is instead of controls living in a spreadsheet or some Confluence document or SharePoint, those controls have to be automated into the systems where developers live. And
Right.
developers live in things like GitHub and Jenkins and other CI/CD pipelines. So how do you automate those controls in those CI/CD pipelines? That is the fundamental question. I think if you start automating controls in CI/CD pipeline, it becomes very natural for developers to just follow and meet those controls. So I think that's an incredibly effective way to do it. Just that doing it is really hard.
Yeah, for sure. And when you and I were preparing for this conversation, you mentioned that there were some best practices that could be put in place, starting with security guardrails. So can you tell me more about security guardrails and how that can be expanded into real world activities or documents or automations, or what are security
Yeah.
guardrails?
Yeah, I mean, guardrails at the end of the day are just protection mechanisms that tell you whether you are in the approved path or not. Like if you go to the non-standard route, if it as a developer, if you go to a non-standard route that's not authorized, not compliant, not secure, then something will tell you that you're going off path, right? So guardrails are going back to our previous conversation, which is controls in the CI/CD pipelines. If you're requiring this control, which is you have to have your code reviewed by somebody else, which in the world of GitHub, it could be a pull request that has to have an additional reviewer, then enforcing that control becomes a guardrail. Like you cannot merge your code unless you have somebody review that code. That just becomes a software control. Now, there are some capabilities in source control systems like GitHub and GitLab that you can force those types of controls. Just managing that is a little bit tricky, but that becomes an example of a control. So now if I'm a developer, I know I don't even need to understand SOC 2. I don't need to understand ISO. I don't need to understand FedRAMP. But the systems where I live, that tells me that for me to be able to move ahead, I need to be reviewing my code with somebody else.
Okay,
Right?
so
Why?
these are some standardized things that are built into how the work is done without making them be your security experts, without making them be your compliance experts. Am I hearing that correctly?
Exactly. Yes. Because like if you put yourself in the shoes of a developer, earlier, 10 years ago, you were only writing software and there was a QA team that would test it. There was a deployment team that would deploy it. And there was an infrastructure team that would manage infrastructure. All that stuff was done by somebody else. Now, developers have to do all of that, right? Developers are writing their own tests. Developers are the ones who are deploying their own code. Developers are ones who are configuring AWS and the cloud infrastructure to run their code. So now, just putting the developer hat on, you have to do so many things. You cannot be experts at all of those things, and add the security angle to it as well. Like if you're expecting developers to be good at security, that's one of the 7 other things that they have to do. They're never going to be experts at compliance or security. So it's our job as compliance and security professionals to make that easy for them. So we reduce the cognitive overload on developers and say, hey, here are the 3 things you just have to do. If you have questions, we'll help you. But if you don't want to think about it, just do these 3 things and you're done, right? You don't have to worry about it.
Right.
And just make it easy for them.
So one of the things that you mentioned was secure defaults. There's ways to set up the CI/CD, the continuous implementation and continuous deployment pipeline for them. There are secure defaults that can be set up in there. And then another thing that you mentioned was vulnerability management. So this is something that I think is a great kind of QA check. So a lot of times you already have QA steps or procedures that are part of that deployment process, and including an application vulnerability management check to it seems to be something that you recommend as well.
Yeah, I mean, it's we've been talking about that. We meaning the industry has been talking about that for a long time.
Yeah.
But here's the reality. What happens is, like, think about the most common source of vulnerabilities in applications today is through open source dependencies, right? That's
Hmm.
it's vast majority of issues come from that. But when you think of it from just testing as a part of QA or testing as a part of CI/CD pipeline, what you're doing is testing the net new code, right? The new code that
Right.
developer added. But the problem with that is if a developer is adding a new dependency today, there's a very high likelihood that that will be the latest version of the dependency. They're not going back and pulling out a 2-year-old version of a dependency today.
Hmm.
So most likely it is free of vulnerabilities today. But what happens is just normal decay happens and those things become stale and vulnerabilities get identified over a period of time. So by next year, I'm sure that vulnerability that dependency that you added today, it will have vulnerabilities by the next year.
Right.
So then if you're testing only the net new code being added, you're not going to see a lot of things. What you'll see is in the overall code base, over a period of time, there are new vulnerabilities get added. So somebody has to think about what's the SLA, what's the remediation time frame of not just net new code, but also things that have already existed. It's just risk that we're incurring. We have to manage that risk. And most compliance standard sort of SLAs, 7 day, 30, 60, 90 days based on the severity of it.
Hmm.
So when those things get identified, developers don't understand why there's an SLA. They don't know what the requirements are. So how do you make it easy for them to see that, okay, this was a piece of code that was added last year. Now it has vulnerability today and it has to be fixed within 15 days. Well, the person who might have added the code last year, that person might not be in your company anymore. So who's going to fix it? Right. So how do you figure out all of those nuances, which is when you get issues, when you get vulnerabilities, who needs to fix it, what is the time frame, what's the right communication mechanism, because developers are not going to go into your GRC tool or vulnerability scanner to look at issues. So how do you communicate those things to the developers who are actually supposed to fix these things, and how do you report it from a compliance perspective? So that whole piece of managing vulnerabilities and risk is a very complicated piece. And it's been around for a long time, but now it's becoming more and more important as more developers start pushing code faster.
Right. It feels like ownership is assigning ownership, taking ownership, understanding who owns the code, not just when it's released, but also, like you said, a year down the road when nobody's developing that piece and it exists, but then who owns it in terms of not just who's supposed to be running the scans, but also who's going to then fix it if a vulnerability comes up, right?
Right. Yeah. And that's the big one, right? Because it's people change, teams change, things change over a period of time. And let's be honest, I mean, all developers want to do the new shiny things. Nobody wants to go back and fix 2-year-old or 10-year-old code. So it's just, sometimes it could be interesting work, but a lot of times it's not for
Yeah.
the developers. So you got to figure out how to convince them or force or influence them in one way or the other to do it.
Right.
And that's where the leadership buy-in comes to the picture, right? So
Sure.
as an engineering leader, typically you want to maintain health of it. So maintaining security health of the software you're building and deploying is also an important task.
So if you don't have as a security lead, if you don't have centralized visibility, if you don't have mature reporting and analytics, that becomes increasingly more difficult, I think.
Yeah. Yeah, exactly. And the one other trend that we are seeing is there's more and more sprawl of technology, right? So now you have different platforms, different technologies, multi-cloud environments. People are in AWS and Azure and GCP, and so many different technologies being used. As a result of that, security teams have so many different types of, scanners and risk assessment systems, and each of them create their own data silos.
Mm-hmm.
So now if you think about a static analysis tool, a dependency scanner, infrastructure as code scanner, cloud scanner, CSPM solutions, all of those things come together, and now you have 7 to 8 different sources of data how do you act on that? Like, how do you know which one is more important than the other? How do you even make sense of it and communicate to the people who need to fix or do something about it? So that becomes a challenge. So that's where the visibility centralization becomes an important initiative to really be able to move the needle forward.
Right. And so, do you have recommendations on how to increase centralized visibility and to really get your arms around that reporting and analytics? Because with that, if you don't have it centralized, how do you prioritize one against another?
Yeah. So what we used to do without a good system in place was we used to funnel all of this data into Jira, and a lot of times it would be a lot of tickets, right? So basically, any task tracking system. And when for most cases of software security, it was okay because it's not high volume in most cases.
Mm-hmm.
In some cases, it is. But infrastructure related vulnerabilities, they're usually very, very high volume, right? So you don't want to create 125,000 tickets and assign it to somebody. That's not going to work.
Right.
So then we had to figure out a way to consolidate those. We used to put it in a central database and then run some queries on it and selectively extract meaningful items out of it and put it in Jira. But the idea, what I'm trying to communicate here is that we have to put those things into one single place, whether it's a Jira or a ServiceNow or a Zendesk or even an open source project like Defect Dojo or a commercial project like Tromso, whatever it is, it doesn't matter, but you have to put it somewhere and then triage and prioritize it. So now you understand, okay, these particular assets are in scope of SOC 2 or FedRAMP or ISO, and I need to treat them with a little bit more care. So we are in compliance versus something that's just internal system, no external access, no customer access. You can treat that a little bit differently. So you have to make those prioritization decisions and then figure out how to communicate it to the right people.
Right. So that centralized view is so important, and being able to choose what to do next, because every organization is has a limited number of people. They have a limited amount of money. They have limits on what they can actually accomplish, and so you might have a long list of vulnerabilities, but they may or may not be something you want to address right away. Like you said, if it's related to high security issue, or if it's related to compliance. But without having a centralized way of looking at it, I don't think anybody can really effectively get their arms around that.
Yeah, you're right. And at the end of the day, vulnerability itself will have like a severity rating, critical, high, medium, low. It might have a CVSS, value to it as well. But just by itself, it's not very important. You have to look at the criticality of the underlying asset, right? Is it a system, application, or a server that's being accessed by external facing untrusted traffic?
Mm-hmm.
Or it's an internal system that two people in marketing use and it's not even accessible from the internet, right? So it depends on what the underlying asset is, and vulnerability scanners will never give you that business risk view. So you marry those two things together in terms of what's the technical severity of it and what's the business risk of the underlying asset. That's how you make prioritization decisions.
Exactly.
And that's a very simple way of thinking about it, right? Like obviously there's so many more sophisticated algorithms, but here's a quick and easy way of doing it.
Yeah, and in practice, it takes time, it takes thought, and it takes some real, usually senior level drive behind something like that is that all encompassing and kind of overarching to prioritize vulnerabilities against each other, especially in the way that you talked about. This episode is brought to you by our SecurityMetrics penetration testing team. They do a lot of pen tests. They do a lot, like network layer, application layer, segmentation checks. They're very, very knowledgeable, and some of them have even won like competitions at DEF CON. So you can rely on these guys to know what they're doing. Head over to securitymetrics.com, learn more about pen testing. So an intriguing statement I found is that application security must be developer first. Help me understand what developer first means and why that's important in application security.
Right. And so the reason developer first is important because Okay, so let's take a step back. So application security or software security, it's the security of the applications or the software, right? Now, who writes those applications? Who builds those applications? It's the developers. So guess what? As security people, we can find all the bugs we want, but we can't really do anything about it until and unless the developers actually agree to fix those things, right?
Right.
So our objective, our mission as security professionals is not to just find problems. That's an important piece, but it's not the end of it. The end of it, the end objective is to manage the risk associated with it. So how do you manage it? First, you have to identify the risk, and then you mitigate it or you treat it somehow. And that's the core component that's outside of our control in terms of how do you treat that risk. That can only be done by the developers who are building and writing those applications. So in order for us to meet our end objective of risk mitigation on the software and applications, we have to get the developers on our side, or we have to work jointly together as a team. And for too long, security has been operating as a very different entity. Security people are typically a team that sits in one corner of the building, doesn't talk to anybody else. And, we all think that we are super important, and we are. But at the same time, it's if you don't collaborate with the developers, you're not going to be able to manage that risk.
Right. Absolutely. So that brings us again to, I think you've mentioned it a couple of times. How do we make it easier? How do we make security easier or more forefront for the developers?
Yeah. So I was just thinking about that, and the analogy that I came up with is probably a really bad analogy. But let's imagine you're driving down a highway and there's a speed limit of 65, but your car doesn't have a speedometer. So you have no way of saying whether you're driving within the speed limit or you're driving at 120 miles an hour. You have no way to tell. Mm-hmm. That's the current state of development today, where developers are building and pushing code, but they have no way to tell, are they doing this securely or are they not doing this securely? We are pumping thousands and thousands of security vulnerabilities into some system somewhere, but that's not even associated with an individual developer's work. It's not associated with a particular team that's working. It's like this global view of here are 55,000 vulnerabilities, go do something about it, right? That's not very actionable. So if you don't have that speedometer for a developer to know how well they're doing, how do they stay within that speed limit? How do they build secure code? So I think that's a key piece that of information that we need to communicate to developers in terms of what is the expectation. We want you as security professionals, we want you developers to write secure code, and that means here are the things you should do. Like you should use security defaults, you should follow, secrets management, you should use these tools for scanning, you should fix these vulnerabilities within X number of days or whatever that is, right? Mm-hmm. So we need to communicate those expectations and give them a way to actually do something about it. That doesn't exist today. So if we are able to make them self-reliant, self-service, that's how we can make a big impact. We can help developers become better at it.
So, but they have to be able to be aware of it first. They have to know the purpose of the company, how to balance that against existing work, right?
Yeah, 100%. Yeah, I mean, just adding on to that same example, even if you have speedometers and speed limits posted, there are still people who get tickets for speeding, And I'm not saying security people should be like cops. That's not how we should be.
Right.
In maybe some cultures, some company culture, it's okay. But there have to be implications of violating security controls, right? Mm-hmm. Like if there are no implications of security controls being violated, then nobody's going to do anything about it.
Right, because it doesn't matter to them, right?
Yeah, it doesn't matter to them. So there are a lot of people who just want to do the right thing. There are a lot of developers intrinsically motivated to write good code, secure code, good quality code. Not everyone is the same way. Mm-hmm. So there's got to be both angles need to be covered, in my opinion. So that's where we get it in a lot of the reporting aspects, where the dev leadership can see what the metrics and the dashboards look like. So then they can be the owners of those decision making. And honestly, this is not different than anything else. Like developers are used to doing this type of measurement and getting better at things from other angles, like quality, performance, scale, reliability. They do this all day long, right? Mm-hmm. It's just the fact that security is not at the same level today because we haven't been friendly enough with developers or collaborated enough with developers so far. Earlier, like 10 years ago, there used to, or there still are in some companies, there used to be completely different teams that would do QA testing, right? So
Right.
developers would write code, ship it to QA, QA would do all the testing, and they would ship bugs back. Like that's where we are in security today. But now, in terms of quality and QA, that world has moved on to most modern companies where developers write their own code, the tests run automatically, they see the results in their CI/CD pipelines, and they go and fix it. They can accept the risk in some cases, but they own that decision. That doesn't happen in security. And a lot of times, developers don't understand a lot of security. So we got to bridge that gap. We got to make security kind of similar to quality, where it just happens naturally in their developer workflows.
And you were talking about motivating people to do good work with regards to security. I know for myself, I am very unmotivated by people being upset and angry consequences. Just yelling it. So when I was young, I had a riding instructor. I did a lot of horseback riding when I was a kid. My jumping instructor happened to be German, and he would just yell at me in German, and I didn't understand a word that he was saying because I did not speak German. Right? So he would be yelling at me, and I knew that I was doing the right thing when the yelling got less. And that's a terrible way to learn anything. So it makes me feel like sometimes we're like yelling at developers about security, and they're going, why? I cannot learn to ride from someone yelling in German. So one of the ways that I think is a really good way to motivate people, especially in our industry, is gamifying things. Have you had any experience with the gamification of that?
Yeah, so we've seen a few good examples of that being done very well. And people go crazy. A lot of times people go crazy with this gamification, build very sophisticated programs, and that works. But there could be something very simple. Like back in the day, in my previous role, we used to build very simple leaderboard of different teams. Our objective of gamification was not the individual developer, because a lot of times they don't care. We wanted to get to the managers, the dev team managers, right? Because managers want to be proud of their team. They want to be proud of the work they're delivering, and they're uber competitive. So we built a very simple leaderboard of every single development manager, and we would bring MTTR metric, like how long did it take your team to fix the bugs that you own?
Mm-hmm.
That's it. Very simple. And we stack rank them based on the teams, not the individuals. We stack rank the teams based on whoever was the best at fixing bugs in a timely manner. And that actually drove a very friendly competition between quite a few of those managers. And that sparked this whole cycle of getting better and better and better at fixing things on time, remediating risks on time. So we've got a few examples of that working quite well.
Excellent. Yeah, I think we've all seen that, where the things that we focus on, the things that we measure, are the things that we can affect. So really a great set of information and advice for people who are looking at increasing security in development. Before we close today, do you have any additional information on working with developers to increase their understanding of security, or create that secure culture and atmosphere there?
Yeah, I mean, I think the only thing I would add, in addition to all the topics we talked about, is it's very important to get both the bottoms up influence and motivation towards the developers, but it's also important to get the top down leadership approval. If you're missing one of those things, it's not going to really work in the longer term. You have to tackle it at both the levels. It sounds intimidating, sounds difficult, sounds like a lot of work, but the results show up when you do both of those really well. If you have your leadership buy-in, developers will spend time, their sprint and their work will consider the time investments that need to be made in security. If you have bottoms-up support from the individuals, they will actually listen to you. They will respond to you. They'll hear you. They'll understand you.
Right.
In a lot of cases, they'll even do better security than what you could do as a security professional. So it's really important as security professionals for us to go both bottoms up and tops down to get that support.
I agree. Some of the best security professionals that I have worked with, most knowledgeable, most capable, are actually they're software engineers. That's what they do, and yet they have a desire to understand and implement good security. And when it all comes together in that way, it's the entire organization is better off, I think.
There you go. That's right.
Thank you so much for talking to me today, and I hope to have you back again in the future.
I love the conversation, Jen. Thank you.
All right. Bye-bye. Thanks for watching. To watch more episodes of SecurityMetrics podcast, click on the box on the left. If you prefer to listen to this podcast, it's available on all your favorite podcast platforms. See you on the slopes.